Hello, my name is Daniel Houston, and this is my Lab 1 constant velocity. In this lab, we will observe an object, in this case a car, moving at the same speed without changing direction. And with this car, we will be making a few assumptions. First of all, the length of the car is 4.9276 meters, and then the mass of the car is 2,040 kilograms, and this is based off of the average weight of a Lexus SUV. For this experiment, we will use Newton's second law to model the position of the car, assuming constant velocity and using the following formula. By Newton's second law, since the velocity is constant, the net force of the object must equal 0. Thus, the formula can be arranged to be set up as the final velocity equaling the initial velocity. This velocity can now be used to predict the position of the car using the position update formula as seen below and build a computational model. As you can see in the graph, comparing the car's position in meters versus the time in seconds, we have the computational model in blue and we have the car's observed position through using tracker in the red circles. It is to note that for the model, the initial velocity that is used is based off the first two timestamps, and this is also used for each time we calculate the position from the position update formula. And this explains why the first two timestamps actually line up with the modeled position. The recorded observations and the model actually line up very nicely, especially at the beginning, due to the initial velocity. However, the model does overestimate the observations slightly due to two possible reasons. First reason is that the road is not actually perpendicular to the camera. Therefore, the car starts to move away from the camera towards the end of the video and making the observed points closer together. Secondly, the camera quality is only 30 frames per second, which could lead to some error in the car's position. Well, if we were to change the positive and the negative x-axes in the video, this is how the data would be displayed. Graphically, this is a reflection across the x-axis and shows the position going towards the negative y direction. Given that the net forces are 0, this does not mean that there are no net forces, but that the forces must cancel out in order to get the 0 value. For example, the force of gravity must cancel out with the surface of the ground in order to achieve this 0 net force. Thank you for watching.